So once you've downloaded the repository or cloned the repository to your computer, you'll see a folder structure that looks like this. And the idea here is just to give a quick overview of what's inside the repository. So the first item that you'll see is something called the device library. And not surprisingly, the device library has the low-level device engines, which are LabVIEW VIs that communicate directly with the devices. Now, this folder is organized into device class. So, for example, all of the laser device engines are inside of the lasers folder, and all of the camera device engines are inside of the cameras folder. If we look inside the stages folder, we can see that once you're inside that device class, things are further organized by device vendor. For example, all of the ASI or prior device engines are inside of the respective folders. If we look inside the PI folder, then we see subfolders for each low-level device engine. For example, if we look at this P612 piezo stage, we find the device engine and any associated sub-VIs. The key point here is that this folder includes a stage messenger, and this stage messenger can communicate with any devices from any vendor inside this class of device. So the stage messenger here could, for example, communicate with an XY sample stage from prior, and then if you use a different system, you don't have to change anything on your user-facing VI because you're still using the same messenger, and maybe now you communicate with a sample XY stage from PI. So the idea is that the messenger VI handles communication, and you don't have to worry about the specific device it's talking with. After the device library, we have a folder called the device manager. This has two folders inside of it. One is the device launcher, and this has VIs which are actually responsible for starting and checking if the low-level device engines are still running. And the second folder we have is a common device queue. So all of the low-level device engines can accept commands on a common queue to do things like quit all the device engines or open the front panels of specific device engines. After the device manager, we have the display module, which I introduced in my first talk. The display module is simply a VI whose job it is to show images, and any VI on the system can, let's say, put a VI on the display module for the user to see. The next is the drop-down VI loader. This is the VI whose job it is to simply display other VIs and would allow you to organize many VIs in a user-friendly kind of vertical arrangement. Next, we have the hardware configuration folder. The key folder in here is the hardware configuration files folder. This is where the configuration file, which says what devices are connected to your computer, actually resides. There is a write configuration file VI. This would be great if you would like to make quick modifications to a configuration file. And we also have a read configuration file VI, which is used by other VIs to pull specific information out of the configuration file. There are some sub-VIs. For example, we have a sub-VI that can find all devices of a certain type inside the configuration file, or we have a VI that can read the entire contents of the configuration file. After the hardware configuration folder, we have the microscope modules, and these are all of the user-facing VIs that the person on the microscope would actually interact with. For example, we have a 4-pi dual DM control, or we have an Orca Flash capture manager. So these are what you would load into the drop-down VI loader to give your microscope some functionality. For example, we have an XY sample stage control. Now, this could be used with an XY sample stage from PI, or it can be used with an XY sample stage from prior. It doesn't matter because the stage messenger talks with the low-level VI, thus alleviating the need for you to make any changes to this VI if you change your sample XY stage. We also have a tools folder, which has a few utilities that can be used by different VIs. For example, we have a few utilities for fitting 2D Gaussian images. We can copy files with progress updates and also the option to cancel the copy. We have a few utilities to grab information out of LabVIEW IMAQ images using their pointers. We have some tools related to sample or microscope metadata. We have candidate selection VI that can very quickly try and identify blink locations in SMS images. And we have some TIFF read and write VIs, which are not based on any third-party libraries. They're all native LabVIEW code. So that's the contents of the folders. Finally, we have a start VI, which is responsible for launching the drop-down VI loader and the display module, and also making sure that the correct hardware and software configuration files get run. So the idea is that you create a desktop shortcut for the start VI, and that's the only thing you ever need to open to start your microscope software. So the shortcut to the start VI is sitting on your desktop, and when a user sits down, they can double-click on that from a drop-down menu, select which configuration files they want, and the start VI will make sure that the appropriate things launch. And that's a quick overview of how the repository is organized.